So question 4 is a solubility product question. Now, this was something that a lot of people struggled with in Big Idea 5, so I would strongly recommend going back and looking at this section again in your workbooks, okay? But I'm just going to go through this problem. In A, it says write a balanced chemical equation for the dissolution of calcium hydroxide in pure water. So this should be pretty easy. Calcium hydroxide breaks apart into calcium ions, Ca2+, and 2 hydroxide ions. 1 point. Nice and easy. Then it says calculate the molar solubility of calcium hydroxide in 0.10 molar calcium nitrate. So the first thing, since it's asking for molar solubility, and because A asked me to do it, I know my equation is going to be calcium hydroxide produces calcium ions and 2 hydroxide ions. I know that. Now, the one thing that really messes people up is we get a little bit lazy as far as our ice charts are concerned. Remember, whenever we're dealing with equilibrium, no matter how confident you are, I would strongly recommend writing an ice chart. The only time you do not create an ice chart is when you're solving for Q. And the reason why is that's your quotient, but you're not at equilibrium when you have your Q value. So that's the only time you create an ice chart. So I created an ice chart here. Now, since calcium hydroxide is a solid, I'm going to ignore that. Okay? For calcium and hydroxide, it tells me that my concentration of calcium nitrate is 0.10 molar. Well, keep in mind, nitrate's just a spectator ion there. Nitrates, group 1 metals, those tend to be spectator ions and don't have anything to do with the actual reaction. So what this is telling me is less that I have 0.10 molar calcium nitrate, and what it's actually saying is, hey, you have 0.10 molar calcium ions. So my initial concentration of calcium ions is 0.10. My initial concentration of hydroxide is 0. So now I'm going to do an ice chart, plus x plus 2x. And so I get 0.10 plus x at equilibrium for calcium ions and 2x for hydroxide. Then I'm going to write my KSP expression. So it's calcium, the concentration of calcium ions times the concentration of hydroxide ions squared. Keep in mind it's squared because you got a 2 coefficient there. Then I'm going to plug this in. I know my KSP is 1.3 times 10 to the negative 6. Equals 0.10 plus x times 2x, the whole thing squared. That 2x, the whole thing squared, is where people tend to slip up, so please be careful with your ice charts. I'm going to get rid of that plus x using my rule of 100, and notice I show my rule of 100. Then I'm going to solve for x, and when I solve for x, I get 0.0018 molar, and remember your x is your molar solubility. So you got 1 point for the correct stoichiometry and setup. I'm assuming it was talking about the plus x and the 2x. For stoichiometry, and then 1 point for the correct answer. In C, it says in the box below, complete a particle representation diagram that includes 4 water molecules with a proper orientation around the calcium ion. Represent water as, and it shows that. So calcium ions are positively charged, which means the negative part of the water molecule, or the more electronegative part of the water molecule, is going to be attracted to the calcium ions. So in that, it's actually oxygen that is more electronegative than hydrogen. So the oxygen atoms are going to be facing towards the calcium. Those are the bigger circles. And then the hydrogen is going to be facing away. If instead this had been a negative ion, it would be the hydrogen that were facing the ion and the oxygens that were facing away. So you got 1 point for the correct diagram with at least 3 of the 4 water molecules oriented as described. Okay, so that was just a total of 4 points there.